thank you all for coming. My name is Javier Godinez, and I'm a security architect at Intuit, where I've been working on securing the public cloud for the last several years. So the Cumulus Toolkit is part of the research I've been doing for the last several years, and it is my attempt to automate securing the public cloud and helping the red team move faster. Something that is near and dear to my heart because, we're making a big push to move into the cloud, and of course, we all want it to be secure. One of the ways I like to secure things is by breaking it. So this talk is concentrated around breaking some of those AWS controls to elevate privileges. The Cumulus Toolkit is not just a set of Metasploit modules, but it's also a set of techniques that we use to get that initial foothold into the cloud. So we're going to be going through a little bit of background on some of the basic constructs for the cloud. And we're going to talk about the techniques for getting that initial hook. We're going to be going over some basic system misconfigurations and some vulnerabilities that help us get that initial foothold. And then we're going to be going over some of the basic modules for the toolkit around creating IAM users, locking users out, and launching unauthorized workloads in the cloud. And then we're going to do a little demo on how to put all this stuff together. And then we're going to have a little discussion at the end about how to stay safe in the cloud. When I say the cloud for this talk, I primarily mean AWS or Amazon Web Services. How many folks use Amazon Web Services routinely? Anybody else familiar with AWS or maybe use some other cloud out there? A lot of folks are still working in their data centers maybe, or maybe having some experiments to move into the cloud. Okay, so that gives a good idea of where we are, but just sort of the basics, right? When we say an instance, we really mean a virtual host. In AWS, things are, instances or hosts are called instances. If you're working in a VMware infrastructure, that would be like a VM. EC2, so Elastic Cloud Compute, is basically built on the Xen hypervisor. It's departed a little while back, but it's basically a modified Xen hypervisor. And instances in AWS do feel a lot like regular hosts running in your data center. That is until you start to dig a little bit deeper. So one of the places where they differ is the metadata service. So the metadata service is this basic web service that can be reached from within an instance. It has no authentication, and any programmer or user can actually reach it to basically discover information about itself. The metadata service will let you know which region you're executing in, what your account number is, what availability zone you're running in, and most importantly for this talk, it's a way to send credentials into your instance. So any SDK or any program that needs to access, say, S3 can quickly get credentials, make that API call, and then sort of forget about those credentials, right? Because they're temporary. So an instance profile is simply a construct that maps a role to an instance. And instances may or may not have roles associated with them. You can spin up an instance with sort of no role behind it, and it won't be able to access S3, but anytime you need to get into any other web service, you would need to give it credentials somehow. The best way to do that is via an instance role. And historically, an instance role, once attached to an instance, you couldn't detach it, but now there's a feature where you can actually, after you're done set up your instance, you can actually detach that role if you wanted to. So here's the very raw, very basic view of IAM, and this is identity access and access management. There are three major sort of constructs: users, groups, and roles. And any of these users, groups, and roles you can actually attach access policies to. Access policies are effectively what gives your users or roles privileges, right? And so access policies have an effect, action, a resource, and a conditions. So effect is simply allow or deny, whether you're allowing or denying an action to be performed. Actions are simply API calls. And if you look at the documentation, it's always prefaced by the service, like IAM, followed by the API call. Resources are the things we're granting access to. So it could be an instance, it could be a bucket, or a user even. And then conditions. Conditions are additional controls that you can use to further restrict your policy. So here's an example of a pretty good policy. This is something you can actually assign to a user, most likely via a role. So what you can see here is that we're using minimum privileges, right? We specify very specific IAM privileges that we're allowed to call. And on top of that, we're specifying the resources where we're allowed to make those calls, right? So this policy, or the initial stanza, says, hey, you know what, I can manage my own IAM factors, right? I can change my own password, I can enable my own multi-factor authentication, I can create API access keys only for my account, right? So this is something that you would find attached to a user account. Furthermore, we have very specific API calls that allows me to do some read-only operations on EC2. So for, say, I'm an auditor that wants to come into this AWS account routinely, I would have some sort of policy associated with my user that looks a lot like this. And lastly, you see the conditions down at the bottom. You know, in the event that these credentials are compromised, they will be largely useless because if those credentials are not used from that IP address that we have there at the bottom, they're effectively useless. Here's an example of a bad policy. And, you know, bad is sort of relative term, right? If I am truly an IAM administrator and I manage IAM for my account, I do want something very similar to this, right? Where I can do any changes to users or groups or policies, right? However, you probably want to have some conditions at the bottom that say, hey, this access is only allowed between, you know, 9 and 5 at night, you know, during working hours. Or you can only use this during, from this IP address range, right? For example, if I have my data center and my traffic always egress inside of my data center, I want to actually have a condition down the bottom that says what my data center IP address sitters are. The last thing I'll point out here is that a policy like this should never be attached to an instance, right? You should really restrict the type of IAM calls that instances, non-humans, can actually make. And here's sort of the ugly, the really bad example of a policy. I'm sure nobody's ever done this out there, right? When they're maybe debugging a little policy, trying to get down to something that's manageable, or something's not working right, we begin to open access a little bit more. Sometimes little by little, sometimes all at once. And oftentimes we end up with a policy that is effectively sort of the God role, right? Which is really pretty bad if you attach it to an instance that is accessible to the internet, right? Any sort of vulnerability that allows an attacker to gain access could quickly lead to you losing complete access over your account. Okay, so now we're going to talk about getting that initial foothold, right? How do bad guys begin to break into my AWS account or my cloud account? There are many ways to do this, and it is by no means an exhaustive list, but it's about 4 examples that I've put together that demonstrate different techniques that are used out there and that I've seen in the wild. So the first one is simply putting an SSH server out on the internet. How long does it take for an SSH server on the internet to get attacked? Right? If you stand it up, put it on the internet, it'll take just minutes for a bot or someone trying to do a brute force attack on it. right? So, you know, anytime that somebody gains access to that host and you have a role like one of those that we showed in the previous screen attached to that instance, they can begin to try to hit that metadata service, and I'll show that example real quick here. But you can see here, basically, I logged in with a weak username and password, and then I can basically use the curl command line to retrieve information from the metadata service. So let's have a quick little demo here to see what that looks like. Oh, hold on, this is the wrong one. Okay, so this is basically emulating, you know, somebody standing up an SSH server or a host with an SSH server listening to the internet, right? And oftentimes you'll be able to find, you know, instant or AMIs or Amazon Machine images in the marketplace that have a default username and password, which is really kind of dangerous, and you should know about these and change them as if you are making use of these, right? But here's another example of somebody leaving a default username and password in place, and me as an attacker coming in and starting to poke around, right? So what I want to do is try to hit this magic local link IP address, right? And begin to crawl around, right? There's a lot, you can see here, there's a lot of sections in the simple web service that will give me a bunch of information about where this instance is running, right? But what I care about as an attacker is that last little bit, that IAM subsection. Guess what we have there, right? Security credentials, right? This really tells you right away that this is where we want to start digging, right? Let me stop it right there. So if you take a look at that curl line at the end, right, you will get temporary access keys. And there you can see the access key, the secret, and the token, right, the session token. And these are actually good for about 15 minutes. So if you know you have that window, you can try to test to see what else you can do, right? So what we're going to do here, we're going to actually exit this machine. And we know those are good for 15 minutes, so we're going to load them into our own environment by setting up our environment variables to use those credentials, right? And the AWS CLI will actually pick these up from your environment. So now we can call AWS actions or, you know, EC2 actions that give us information, right? This rule actually allows us to do a lot more than just list what's in the account. We could actually start instances, destroy whatever's there, steal data, right? There's a lot of things you can do. But this is sort of the initial sort of proof of concept to show you how dangerous it can be to sort of leave a host with a default password out on the internet. Okay. Does anybody use Jenkins as their build platform? It's often used by development teams because we need a CI/CD pipeline, right? So Jenkins has historically had bad security. I think it's getting a little better in the later years, but initially it used to be you bring it up, it would have no authentication, or you could create a user by clicking the create user link. And the thing about it, the cool thing for an attacker is like, hey, it's got a scripting console that I can throw some Groovy code in there and execute commands on the host, right? Anytime that you have an application that allows you to perform command injection, we can begin to tailor that to hit the metadata service, right? So here's another example of what can be done, right? Something that's very similar to the last example that we saw. But really, if you have a Jenkins host, make sure that you enable authentication, enable strong usernames and passwords, right? And that you that you restrict the creation of users, right? Because oftentimes we say, hey, we enabled authentication on Jenkins, which should be good, but then somebody could just create a user account and be authenticated, right? So you gotta make sure that you put some time into thinking or think about how to secure it, right? If it doesn't need to be open to the internet, don't open it to the internet. Oftentimes we're in the mindset of deploying these things in the data center, but when we're operating the cloud, anybody can see our resources, right? Because it is easy to open access to 000/0, right? Anybody on the internet, when only me coming from my home or me coming in from my data center need access, right? So you can restrict your security groups as well. So here's an example of what Jenkins looks like. By default, no authentication. Click on the scripting console, and then you can get a little recipe that, basically this here will list the file system. So if you scroll down, you see, oh, look, it's a Linux file system, right? Again, thinking like an attacker, I will want to take a look at that metadata service, right? That magic URL that tells me, where this account's living, what's there, right? And of course, since I already know the path, because it's the same one as we saw before, right? We can retrieve those API access keys in the same fashion that we did as if we had logged into that instance via SSH. Okay, here's the third example. Oftentimes when we're operating in a VPC or a virtual private cloud, that is sort of a local area in a local area network in AWS. If depending on what your subnet layout looks like, you may need a proxy to proxy HTTP calls from, say, hosts that run inside to the internet, right? So one of the experiments that I ran was to search for a Squid proxy in the AWS Marketplace, and sort of the first one that popped up, I spun it up and I opened access to the internet to the Squid port, right, which is 3128. So Squid, if you're not familiar with Squid, Squid's essentially just an HTTP proxy. If you need to traverse networks, you can use it to allow something running in a local area network to talk to the internet, right? Well, the dangerous part about opening this port to the internet is that anybody can proxy calls through your proxy. And they could even proxy calls to your metadata service, right? So, of course, I tailor this attack to attack the metadata service and retrieve those API access keys. And I really thought that, when I ran this experiment, that for sure the metadata service would have been blacklisted in this proxy that I spun up. It was the first result. I figured that's got to at least have some security, right? But no, you really should check anything you pull from the marketplace, check what's running in the background, see what's, what the configurations are, and look for those safe configurations. If you're running something like Squid in AWS, you should really blacklist that URL so that nobody, even other instances running within your VPC, can access it, because they will be getting the wrong information. They will be getting information for the proxy itself, and not for the instances that that are inside your VPC. So here's another example of how we can exploit this issue. Sort of the third foothold that I'm showing here. Okay, so we did a basic port scan on that IP address for 3128, and I imagine if you scan all of the AWS IP address ranges, you'll see more than one running out there, right? So that 3128 port is kind of important. So again, using my command line tool here, I just set the HTTP proxy environment variable. And then now I can simply use the curl command line to hit the metadata service, right? And so what's happening here is that my command line tool says, hey, proxy this HTTP request through that IP address, that 34.211.83.90. So whatever call I make in this shell through curl, send it to that host so that it can make it, so that it can proxy the request for me. And sure enough, it accepts that metadata IP address. And again, lo and behold, you call that the URL, and you can download and you can get the API access keys. I'm sort of beating the dead horse here, so this is the last example, I think. Yep. But you get the idea, right? Anytime you have some sort of command injection or a proxy, oh, actually I have another one. Sorry about that. I do have one, but this one's actually a little bit cooler, right? It's a, anyone familiar with XML parsers? Use them in your project maybe? So XML parsers have somewhat of a flaw in the specification, right? XML says, hey, if somebody wants to load an external entity, allow them, right? That's sort of the default specification. So XML entity injection is a serious problem that allows, attackers to say, hey, give me this resource from, say, the underlying file system, right? So what we're showing here is the vanilla sort of XXE vulnerability being exploited, right? So as a bad guy, I have basically, so this is an example web service that allows me to manage sort of my library, right? So it's a simple REST API that lists books, right? But what I can actually do is upload a file that tells it, hey, retrieve a resource from the file system and enter it into a field in the XML. So let me just show you what this looks like. Gives you a better idea of how troublesome this can be. So here's my simple API, right? I have a REST API that lists basically a couple of books, right? So it's a simple GET request, right? And if I want to upload, I want to insert a new book, basically I specify an XML file, and I do a put request to upload basically this new book into the list, right? So in a minute here, I'm going to curl my list of books, and now I have 3 books, where before I had 2 books listed, right? So I inserted a new book. And now this is an example of me using the XML entity injection flaw, right? Basically I'm saying, hey, and this is just part of the XML specification, retrieve this file from the file system and put it in the author field. This is sort of the vanilla XML entity injection attack, right? And sure enough, the XML parser does what it's supposed to do, right? It reads etc password from the file system and stuffs it into the author field, right? So first we upload that XML file or that XML request, and then lo and behold, you see that the contents of that file in there, right? So XXC can be used for more than just retrieving resources from the file system. It can actually be used to retrieve resources from the network, right? So what are we going to do here? Retrieve that metadata service, right? This is sort of a cool one, right? And it's a vulnerability that's out there. So again, we upload our malicious XML, and we request our list of books. And again, my 5th book that's in here has the author of API access keys, right? And so this is sort of the 4th and last example that really beat the dead horse of like, anytime you have a sort of a flaw in your configuration that allows somebody to, run commands on your infrastructure, or you have even a web application that allows, somebody to proxy calls through your application, you open yourself up for attacks on the sort of cloud attack surface, right? Something that wouldn't be possible in the data center before. Okay, so now we're going to get into the Cumulus Toolkit. Those first 4 things were just about the techniques that you can use to get that initial foothold. But first, let's talk about a little bit about Metasploit. Metasploit is an exploitation toolkit used by penetration testers, security researchers to develop exploits. And you can use it just as a testing tool to test your controls, right? It has session management and has automation of shellcode that I can use without having to write the shellcode myself. So what I did is basically I built a set of modules on top of Metasploit, right? Because I didn't have to worry about doing the tool from the ground up. I can concentrate just on the exploit that I wanted to write. So this one here, the first module that we'll be taking a look at is the CIMU module. Basically, it's a post-exploitation module that you can use to create a user in an AWS account. So if I have a foothold into an account with one of the techniques I described earlier, I can actually leverage this module to say, hey, create me a user into that account and give me some long-lived credentials, right? And by default, if you don't specify sort of the group name, password, or username, it'll create those random for you. So you can make sure you set up if you're sort of following along. The second module is the launch instances module. That, as the name describes, this module can be used to launch instances or hosts in an AWS account once you have some temporary credentials or long-lived credentials. You can also use this to escalate privileges because oftentimes we have the capability to launch instances but can't do much else. Well, with this module, you can launch an instance and at the same time attach a role, right? If you give it an admin role, you can actually log on to that instance that you've launched later on and then create a user and perform other IAM actions that you couldn't before from that initial foothold. And lastly is the lockout users module. This module is sort of the evil module. Please don't run it in production. It's basically you run it and locks everybody else out except the user that you have specified or the user that you're actually logged in as. So before we get into the demo, just want to say a disclaimer. This is not an AWS specific issue. Many of these techniques can be are applicable in other host cloud providers. This is really a DevOps and education issue. This is sort of why we're doing this. This is why we're at this conference, is because we want to be cognizant of these issues and harden our infrastructure and take responsibility for our configurations and our deployments. Okay, so we're going to do a quick demo of a walkthrough from that initial foothold all the way to the elevation of privileges, right? And so we have this test network. I'm up there, little ninja, right? And the basic setup is, like I said before, it's a VPC, a virtual private cloud, and these 4 hosts at the bottom here that basically you already saw, right? You have the SSH server, the API with the REST, with that weak REST endpoint, the proxy that's open to the world, and have that Jenkins host, right? So for this demo, we're going to be exploiting that Jenkins host, taking advantage of the rights it has to launch a secondary, or I guess a 5th instance into that account. So we're going to be launching basically an instance, an attacker instance with more privileges, and then we're going to log into that instance and create a 9 AM user and then lock everybody else out. So let's take a look real quick at what that looks like. Okay, so the Metasploit console, again, I like the command line. It's very, there isn't too much to it, right? It's basic commands. They have pretty good documentation if you want to take a look at it. But if you have any questions, please ask me, and I'm happy to explain anything you see. So the first thing we're doing here, we're loading, and this is one of the benefits of using Metasploit for me, right? I didn't have to write this exploit myself to get that initial hook, right? And this is basically a module that leverages that vulnerability that we saw earlier around Jenkins. Basically, it executes a piece of code on that Jenkins box through the console and sends me back a reverse shell, right? So once I execute this command, I will have a shell connected to my attacker box, right? So let me stop it right there, and we can see. So basically, to configure this module, you specify the remote host, the port, the URI where the Jenkins host lives, and this one just happens to be /. And then you define the payload, right? And for this, we want just a reverse TCP connection back to our attacker host. Lo and behold, we run the exploit, and we have an interpreter shell, which it's basically it's a penetration shell that allows you to dump memory, do a whole bunch of actions. For this one here, I just basically spun up a simple shell, and now I am listing the file system. And one of the things that I want to see, hey, well, I'm on the instance, right? I'm basically, it's kind of like SSHing onto the instance. I'm going to try to create a user, see what happens, right? And as it turns out, I can't just create a user on this account. A little bit more testing, and I would actually realize this instance does have other privileges, right? So what I'm going to do here is, again, print those temporary access keys by hitting the metadata service, right? So once I have those, I can actually exit. I'm back in my attack host, and I can launch I can use the launch instances module here to leveraging those API access keys to launch that attacker instance that we talked about. So again, we just configure the parameters, the API, or the access key ID, the secret, and the token, right? Once we have those, for this module, we have to configure a few other things. Since we're spinning up an instance, we got to tell it which SSH key to use, what the key name should be. And this is, if you're familiar with AWS, it should be pretty straightforward. It's sort of the key pair for SSH. The beautiful thing about this module is that it does some auto detection for you. You don't have to specify the subnet or the security group. It'll actually create that security group for you. It'll auto detect the subnet to launch this instance in. And once you run it, it takes a little bit. So I skipped forward here to, it actually takes only several minutes to launch an instance. But it'll come back with an IP address, a new IP address for that host that you just spun up, right? So now what we're doing here, we're using the SSH login module to actually connect into that host that we just spun up. A little hard to see because it went by kind of fast, but we essentially just, we're setting our, we basically configured the module, launched it, and now we have a second session connected to that host that we spun up, right? So now we can essentially log into that host by doing a, oops. Let's see. Okay, so that second session, we're not using it. We're using the create IAM users module to create a user through that second session, right? So this host that we spun up actually, let me back up a little bit just so that it's a little more clear, because I missed it because it was going a little fast. But one of the things that we did here when we were configuring our host that we were going to launch, right, is set a role. And this is an admin role that exists in the account already, right? So what that does is we're actually launching an instance with an overprivileged role, right? And that's sort of the key here. Again, once it initializes, it'll spit out that IP address. And now we use another module called SSH login to connect into that host and have that secondary tunnel onto that attack host that we spun up in the AWS account, right? So here you can see the ID of our session is 2 instead of 1. So here now we're using the Cumulus CIMU module, right? And this is basically a module that allows us to create users. but it does depend on the instance where we have that hook to have the privileges to create the user, right? And that's exactly where we are now. Here we specify the session that we want to use, and we tell it to create API keys and a user name and password for us to log in, right? So once we run it, it comes back with an actual URL that we can use to log in, right? So this is where sort of the money shot is of like, hey, it's cool that you're doing all this stuff in the command line, but the execs want to see a screenshot of the console, right? They want to see the resources exposed, right? So here you can see that it created a user called CodeMonster, and then it sets a password for it. So you can actually use that URL to log in with those credentials. And now we can go take a look at sort of the resources that we said we had in here, right? And here you can see those 4 hosts that we had, and then the new host that we just spun out. That one with no name there is our attack host, and you can verify that that's the IP address we used to connect to create that user. Right, here's that Jenkins host that gave us that initial foothold in this use case. And now if we take a look at its role, the role that it has attached, you can see that it's sort of a bad role, you know, an instance. Actually, it's not that bad, right? I mean, this is something that you would want sort of your pipeline, your code pipeline to be able to do, right? Launch instances in EC2 and give attach roles. So this is kind of like a usual use case, right? Something that, you know, it's somewhat reasonable to have out there, right? But the thing is that if you have a role that is an admin role, sort of a non-powerful role that is allowed to be assumed by instances, that's where you get to be, that's where you start to get into trouble, right? Because we were able to launch a new host with an admin role, right? That role should never be allowed to be used by EC2. It should only be maybe a human role. So if we go take a look at that role, it's sort of the ugly role that I showed earlier, right? So the access policy will show you, hey, it's any action on any resource, right? There's really no use case for this kind of role, right? And here we can see we're now releasing all the users in that account, right? So now we're going to use the evil module, the lockout users module, to actually lock everybody else out and show that I have full control over that AWS account, right? So here we're loading that lockout users module. I set the access key and access secret key in the configuration. Once I learn how to type right, or at least copy and paste. Yep. So once we set those, we can basically just run it. There's a built-in safety mechanism to say, hey, this is not a dry run. So here you can see that everybody else in this account has been locked out, right? So we just refresh, and you can see everybody else but myself has been locked out, right? And then, of course, I left myself a little backdoor in case I fully locked myself out of this account, right? And now you can see that, you know, if you run this module, you will remove everybody's password and you will disable all their API access keys. So don't run it in production, please. Okay, so that's the end of the demo there. What I do want to show you guys is sort of how do we stay safe, right? I mean, we've talked about how the bad guys take advantage of us, right? So let's talk a little bit about how to stay safe. Sort of the best practices from the documentation are pretty good. I have modified them and amplified them a little bit, just because this is my added benefit here. So by, right off the bat, secure your root accounts, right? Your root account is sort of the initial user that is delivered to you when you create an account, right? So make sure that you remove their API access keys. There's no need, really, anymore for the root user to have API access keys. Enable MFA and strong password on that root user, and lock that MFA and password in a safe somewhere. Never use it, right? Unless you really, really need to. Create individual IAM users, right? Instead of sharing users or IAM users between developers, create one for each. Grant least privilege, right? This is sort of hard to do, but it is worthwhile. Enable MFA. You can use your smartphone to put an MFA token on each one of your IAM users, so I highly recommend it. And use roles for your EC2 instances. We saw how we could take advantage of some of those roles attached to the instances. But if you need your instance to make calls to other AWS services, you really should be using roles because that'll allow your instance temporary keys, right? The alternative of that is to create an IAM user, create access keys for that user, and then stick those keys in that instance, right? And so your instance has long-lived credentials in it, which is really bad, so don't do that. Much better to use roles, right? If your instance only needs the role for the time that it's being set up, when you're bringing it up and bootstrapping it, you can remove the role once you're done with it. So I recommend you do that. It is a new feature. I think it's only been around for the last couple of months. But I really encourage you to, if you're not using a role in your instance, you only need it for sort of bootstrap, then take it off and remove it after you're done with the bootstrap. So something about role delegation here. If you ever need to share data between your a third party and your account, instead of creating an IAM user for that third party or for that vendor, it is better to have them provide you a role, and then you can grant access to that role from your account, right? So you can allow them to assume a role into your account with limited privileges, right? So that's sort of the better way of doing it. That way you don't have to manage keys, or you don't have to say, hey, here's your password, right? Make sure you go change it. They manage that on their own. And make use of policy conditions, right? We saw how, how easy it is to forget to do those things, but sort of try to use, the controls that the cloud provider gives you to secure your infrastructure. And lastly, here we have monitor CloudTrail. CloudTrail will tell you every time somebody makes an API access call. If you're running in the cloud and not using CloudTrail, I really recommend you start looking into it. And here's sort of the link for the best practices. Some of the other things that I put in here is, practice separation of duties. It is hard to do in AWS, but it is doable. You have to spend some time in your IAM policies, right? Not everybody should be able to perform any IAM action, right? So in a group of, say, a dozen folks that are working in one account, only 3 or 4 should really be IAM administrators, right? Somebody that can create users, create roles. It does make operating in the cloud a little bit harder, but it'll give control to your administrators, right? It'll make it so that not everybody is an administrator. You won't have that administrator sprawl. And beware of tunnels. Anytime you connect or VPN from your AWS account into your data center, or by peering into another AWS account or to another host, you open yourself up to an attack, right? Because attackers can certainly traverse from an account they broke into your data center or vice versa, right? So don't use VPNs if you don't have to. And when you do, you should really be using a secure DMZ so that you know exactly what's coming through that pipe, right? And lastly, make sure you lock down your security groups. There's no reason why we should be having SSH open to the world anymore, right? We should really be restricting those access points to only the IP addresses that need access to them. And monitor CloudTrail, I mentioned it earlier, but will you know when somebody creates a resource in say a region that you never use? Or will you get an alert when an IAM user is created in your account by somebody who wasn't your IAM admin, right? So monitor your CloudTrail. CloudTrail will tell you when these actions take place, and so you should have alerts, that actually wake people up in the middle of the night when these things happen, right? They shouldn't be happening in the middle of the night. It should be happening during normal business hours. Test your security. Does a lot of us perform penetration tests, vulnerability scans, we do red teaming, we have threat models. Do these things include your AWS footprint? A lot of times those are sort of forgotten, right? And we've got to be aware of the sort of new attack surfaces that the cloud brings.
And lastly, it's awareness. You know, we're all here, so obviously we care about security. You know, read the IAM best practices. There's a bunch of white papers online that you can find, and you know, build a community. You know, if you don't have a cloud security community within your environment, you know, you can start one. So, you know, if you have any questions, please let me know. But that's all I have for you guys. Thank you for coming. Appreciate it.